you guys to do is I'm going to give you about a minute or so here, and I want you to simplify these. So what I want you to do is first start off by setting it equal to y, use the circle of life to rewrite it, and then try to use your brains to figure it out. And if you get stuck, check with the neighbor. Once you have an answer, you can check it in your calculator, okay? So I'll give you a couple minutes here. Try these out. And if you have them, check with your neighbor. You guys are being really quiet, but it's better to talk and put your brains together. I'm going to call on 3 of you guys to do these, but you can choose which one you do. You're going to rewrite and tell me what it would simplify to. Let's send this to Kara, Josh Wood, and then Josh Lim. Both Joshes together. So Kara, you can choose which one you do, but tell me, how would you rewrite it, and what would it simplify to? So what power of 7 gives you 7? It's just 1, right? So I should get 1. Thanks, Kara. All right, Joshua, which one do you want to do?
D.
Okay, how would you rewrite that?
So I did 4 to the power of y equals 1. And if the exponent makes it equal 1, it's 0.
There you go. Anything to the power of 0 turns it into 1. Good job. All right, and then lastly, Josh Lim, how would you rewrite log base 5 of 1 over 25? All right, that one's a little tricky. What were your thoughts there? Well, if this had just said 5 to the y is 25, that'd be pretty easy, right? What is it? What power of 5 gives you 25? It just be 2, right? But then how do we make it a fraction? How would we make it 1 over 25? Make it a negative, because in a negative it changes your position. A negative exponent changes your position in a fraction. So 5 to the negative 2 is going to move it to the denominator and then square it. So you're right, this is negative 2. You can check your work on your calculator, but guys, a lot of these you should be able to just do in your head, right? So try to figure it out in your brain first and then do it in your calculator. All right, good job. Do you have any questions on this? This is kind of like your foundation, the foundational skill is to be able to switch them back and forth. Because this is kind of easy now, but when we get into solving, when we get into finding inverses, even with graphing, we're going to be switching back and forth, so you have to make sure you understand how to do all about that base to go from an exponential to a logarithm, and circle of life for going from a logarithm to an exponential. Okay, now we're going to go through some of these basic properties. They're kind of like shortcuts that will just help things go by faster, okay? And we saw a couple of these already, but here's one. Log base b of 1. No matter what your base is, if the argument is 1, it's going to turn it into 0, which is saying, why? Well, let's think about that. If I rewrite this, I get b to the 0 is 1. And no matter what b is, what is anything raised to the 0 power? It's 1. So no matter what the base is, if the argument is 1, it turns into 0. Does that make a little bit of sense in your brain? Okay? Now, what if the base and the argument are the same number? Well, then that means the log will turn into 1, because, rewrite it, circle of life, b to the 1 is b. Anything to the 1 power stays the same, right? It doesn't change. So if you see your base and the argument match up, then that means you're good, okay? All right, now, this one is going to come up quite a bit, a little, in one of our properties, so in the next section. So it'd be good if you understand it now. If your argument is raised to an exponent, to a power here, then this whole thing, and the bases match up here, then this whole thing just simplifies to y. You're like, why? Well, rewrite it. We would say b to the y equals y. And so it just, the whole log base b just goes away. So if you have, just like what we saw before where the base and the argument matched up, it became 1. Well, if the base was raised to an exponent, it's just going to turn into that exponent. So if you say log base b of b to the y, it just becomes y. Okay, similar thing but with exponentials instead of logarithms. If you have an exponential base raised to a logarithm and the bases match up, see the base and the base are the same, just cross it out, it becomes x. Now, these will take some practice to get used to, but we'll do some examples here to make sense of that, okay? Okay, now, I feel like some of these, okay, yeah, let's go through these real quick. I feel like we just did some of these though, didn't we? Log base 2 of a, yeah, we just did those on this page, right? But let's do C. Notice here I have 6 raised to log base 6 of 11. Which one of those properties can we simplify this with? Yeah, I heard someone say the bottom one, right? Notice I have 6 raised to log base 6 of 11. Since the 6's match up, I just kind of cross it out, and that just becomes 11. So one of the cool things we can do with logarithms, make sure you keep your properties close by so you can keep track of those. How can you check that? Put it in your calculator, and it's going to work out, okay? All right, let's just keep on rolling here, okay? Because we've covered the basics, but now we've got a lot more to cover here in a little bit. But let's go. Now, let me tell you, there's 2 types of logarithms. So first off, look at your calculator, and where do you see the log button? You see it on the bottom left? Okay, now I want you to go into your calculator and push the log button. And notice when you do that, does it let you put in a base? No, it just goes straight to the argument, okay? Now, this is what we call a common logarithm. In a common logarithm, the base is 10. But since we use this one so often, so commonly, we don't even write it. So if you ever see a logarithm without a base, for example, if I saw log 100, that's really log base 10. If they don't show the base, it means it's 10. Because we use it so much, we get bored of writing it, so we just kind of write it like that. But now if I think about that, I would write that 10 raised to what power is 100? And you would say, what power of 10 is 100? 2. Will you check that? Is log, common log 100, 2? Yeah? Awesome. Okay, so there's 2 main type of logarithms. You can let any number be your base as long as it's positive. But the 2 main types we have was we have a common log, which means if you don't see the base, what is it? It's 10. Okay. So now let's just look at these properties here real quick. Notice for all of these logarithms, it's not showing a base. What does that mean the base is? 10. So if I do log of 1, it will become 0. Why? Well, what power of 10 gives me 1? It would be 0, right? Kind of like the last property, but now our base is 10. Will you check that real quick? Put in your calculator log 1. Does it give you 0? Okay, cool. Let's do log 10. It should be 1, but why? Well, because the base is 10, and if the base and the argument match up, it becomes 1 because 10 to the 1 is 10, right? And then I can apply these other two. But basically, it's the same properties, but now our base is 10. Okay, turn to your neighbor. I want you to do these 4 without using your calculator. Just try to simplify it on your own and then check it with your calculator. I'll give you about a minute or so, okay? All right, go to work on this. Okay, let's go through this. I'm just going to have you guys shout it out, okay? So on part A, we already did it. Common log of 100 just turned into what? 2, because 10 squared is 100, right? Common log, 5th root of 10. What do you guys get here? It's 1/5. Good job. Because if the square root is 1/2, what is the 5th root? It's 1/5. Now, if you put this in your calculator, you probably got 0.2, right? 0.2 is 1/5. All right, you with me here? Let's go over this because I'm getting confused looks. So if I were to rewrite this, I would say, so remember, this is a 10. Oh, hey. Thanks for telling me. I'm like, why is no one like comment? Okay, here we go. There we go. Okay, so now, if I were to rewrite this, okay, I'm going to say 10 raised to what power gives me the 5th root of 10? How can I rewrite the 5th root of 10 as a exponent? Be 10 to the 1/5, right? So therefore, y is 1/5. You can check it that way. Cool, cool, cool. See, what did you guys get? Good job. Because 10 cubed is 1,000. If I want to do 1 over 1,000, I would just do -3. What about D? Good job. Using those properties, the 10 and the 10 match up there, so we're good. Okay, let me just go back. I forgot to kind of highlight something here. Okay, so I'm coming back to this. Notice your base always needs to be greater than 0, but it can't be 1. And then also your arguments need to be greater than 0. That means your arguments need to be positive. And you know, I think that's a good life lesson. Your arguments must be positive. It's okay to disagree, but let it be positive. Okay, so highlight that. Let's just go real quick. how do I put these in my calculator if I don't, like, how would I put this in if it doesn't simplify? Well, then you just put it in. So for example, will you guys go on your calculator, log 34.5. So this is common log, it's base 10. And what did you get? What is it? 1 point what? Awesome. So 10 raised to 1.537 is about 34.5. What about 0.43? Thank you. So since it was less than 10, right, I had to turn it into a fraction, which meant I had to make it negative. Awesome. Last one, log of negative 3. What is that? Why? This is undefined. How come? Because the argument was negative. And what did we say about our arguments? There we go. So it needs to be greater than 0. And it wasn't. So that's kind of a trick question you'll see. They'll ask you to evaluate a negative, and you just say that's undefined. Okay, cool. Let's keep going here. Now, we're going to use this rewriting method to help us solve for logarithms, okay? So when I get here and I say log of x is equal to 3, and I say, hey, I want you to solve that, people will be like, how do you undo a log? Can you subtract a log? Can you divide a log? The only way you can solve this is by rewriting it. Now, in this case, we're doing circle of life, and you start at the base, but there isn't a base. What does that mean the base is? 10. Good job. So now let's do circle of life, and we'll say 10 raised to 3 is equal to x. What is 10 to the third power? And then you would check that. You would go on your calculator, common log 1,000, does that become 3? Go and put it in. Boop, boop, boop. Sure enough, it does. Yes. Hey, Mikkel, on B, how would I rewrite this using the circle of life? So then I would go on 2 to the 5th. Is that 64? Someone help me out there. 32, I was close. Alright, so then I go and I put that in as log base 2 of 32.5. It is cool. We're going to get to a little more complicated ones later on, but this is just kind of giving you a heads up. Hey, how are we going to learn how to solve logarithms? We're going to use rewriting it as an exponential, okay? Now, we've only learned about one type of logarithm so far. We're going to learn about another type. Does anyone know the name of the other type? Don't spoil it if you do. But this one, you'll be surprised to know, is actually pretty common. As a matter of fact, there's like pop culture about it. Let me play the song for you. Oh, come on. It's a natural logarithm. Okay, go back. Hold on, we had to change the words a little bit. So, where he says, you're standing on the edge, you got to sing it with me. You see, because a logarithm with a base e is called a... Okay, let's go back. You got to play it. Because a logarithm with a base e is called a natural. Alright. Anyway, there's more than that, but we'll just keep going. So anyway, the second type of logarithm that we like is a natural logarithm. What is a base? E. Alright, we've seen this before, but now you're going to have it stuck in your brain. Okay, so common log, what is a base? 10, because it's so common. Our counting system is 10. You have 10 fingers. It's common, okay? But natural is base E, okay? So whenever you see, if you were to have a log base e of x, we're going to rewrite that as a natural log when we do ln of x. I don't know why it goes ln and not nl. Maybe it's a logarithm that's natural. But anyway, if you see log base e, write it as ln. Or if you see ln, think of it as log base e. And if you were confused between the two, just remember that this type of logarithm happens naturally. Naturally. Baby. Selena Gomez. You know that song? My last class didn't know it. And I was like, you don't know Naturally by Selena Gomez? Well, of course you don't now. They listen to Metallica, okay? That's okay. Okay, so now I'm going to play that for you later. But natural is base E, common, whatever, okay? Now let's just go through those properties real quick. So if you see ln, it means natural log, which means base E. So if you do ln of 1, that will become 0 because e to the 0 is 1, right? If I say ln e, well then I have a base e and an argument e, so that will just become 1 because e to the 1 is e, right? So the properties that we've seen before, they still apply with natural logarithms, just as they did for common logarithms, just as they do for any logarithm, okay? Okay, so let's do a couple of practice here with our properties of natural logarithms, okay? Let's say I wanted to simplify this. Evaluate means kind of simplify. What is the ln of the square root of e? That looks scary, but it's really not. So now, what did you guys tell me about square roots? How can we rewrite that as a rational exponent? This would be ln of e to the 1/2. You guys okay? A squared is a 1/2 power. Now look at your properties. What happens when you get ln of e? It's going to become 1. What if there's an exponent? Well, then it just simplifies to that exponent. So what is that going to become? Good job. How could you check your work? You plug it in your calculator and it gives you 0.5. Hey, what about b? Shout out what you think your guess is that's going to simplify to on b. 5, right? If you have ln, which is log base e of e, it's just the same as this last one, but now our exponent's 5, that's going to be 5. What about on c? I have e raised to the ln of 4. Well, that's the same as like e to the log base e, so the bases are the same. So this is going to be our last property. It's just going to cancel out except for the 4, so that is 4. So same properties you've seen, just showing that ln, which is natural log, still applies. Do you guys see ln on your calculator? So, just a quick history on this. People used to not have calculators, right? And so they would have to use books with just tables, pages of tables for different bases. Well, the two most common that were used were natural logs and common logarithms. So when they put it into your calculator, they just only put in those two types. Okay? Now, if you guys, who has their own graphing calculator? You do, right? You do. Do you have Math Up on your calculator? You have yours. So what if you guys aren't able, what if you don't have Math Up, okay? Or what about when you go home? How would you put in log base 2 of 8 if you have a calculator that only does a common or a natural log? Real quick, let me show you this. It's called the change of base formula. All you're going to do is you could use a common log and just do log 8 divided by log 2. So will you try that on your calculators, guys? Instead of doing Math Up to get log base 2 of 8 is 3, put in common log 8, close the parentheses, divided by common log 2. Do you get 3 that way? Awesome. This is called the change of base formula. It also works with natural logarithms. So if I did let's say I want to do log base 3 of 9, okay? I could do ln 9 over ln 3. And I would still get that it becomes 2. So you can use a common log or a natural log. Just make sure you put the argument first and then the base. Okay? Cool. Let's keep on rolling here. So then you would put these in your calculator and you would check it, and I'm not going to take the time to do that. So you guys can plug it in just fine, right? What's going to happen on C when you plug